Hey team, it's Mr. Z, and we're going to continue where we left off, where we were dilating basically a line by another line, resulting in the quadratic below. And we're going to go ahead and review some key things. So let's go ahead and start. Okay, connecting the whole piece. Now, m of x is graphed below, but the idea is that you should understand that it is in factored form. And basically this means without graphing it, I know that the zeros, and I also know what the concavity is. So let's go ahead and look at both. The general form of a function is going to be x minus root 1, x minus root 2. The a value is going to be between or right in front of the first term. Now notice how there is no number here. Well, that means that the value is assumed to be 1, a positive 1, which means it's going to be concave up. Notice how my prediction matches the graph to the left. I also know that the zeros, root 1, root 2, should be like so. Notice so that my 0 here is at negative 3. Notice 1 is where it's supposed to be. That's because when I'm looking at this, notice how above 1 comma 0 is a 0. If I think of the above as x minus a negative 3, notice how it matches the form. The other 0 is going to be negative 3, 0. And you can see both of them. Remember, it's kind of going by 2's. So negative 3 is going to be between negative 2 and negative 4. All right, that was unit 1. Basically, quadratics, looking at factored form, and the key information that it displays. Let's go ahead and now figure out what we need to do. We need to dilate this function by a factor of x plus 3. We're going to be multiplying it by x plus 3. So let's go ahead and look at my table. My inputs, and then my outputs. So let's go ahead and say 2, 1, 0, negative 2, negative 3, and negative 4. So what are the outputs? Now, you can look at the graph. For example, I can look at the output of 2 and see that it's 4. I can look at my output of 1 and I see it's kind of in the middle, right? Where is the output? Oh, it's in the middle. That means it's 1. It's on the x-axis, which means it's going to be 0. At 0, it's going to be negative 3. But I can also figure it out by plugging it into my equation. Those of you who like algebra, you can plug it into the above equation. Notice all I did was replace all of my x values with the input. And then I would get negative 3 times 1, which is going to be negative 3. Notice negative 2, if I looked at it on the graph, it would reveal the same thing. Let's keep on going. Negative 4. We can see negative 4 is just right there. Okay. Now, we have to multiply it by what? A factor of x plus 3. So I need to take my function, my outputs, and I'm going to multiply them by x plus 3. So what is x plus 3? 2 plus 3 is 5. 1 plus 3 is 4. 0 plus 3 is 3. Negative 2 plus 3. Oops. 1, 0, and negative 1. Okay. Finally, to figure out what r of x is, I have to multiply m of x, and I have to multiply it by x plus 3. This is going to produce 20, 0, negative 9, negative 3, 0, and negative 1. The points, however, are all going to have the inputs. These are the original. And then the output for 2 is 20. The output of 1 is 0. The output of 0 is negative 9. Negative 2 is negative 3. Negative 3 is 0. And negative 4 is negative 5. Okay, I'm going to graph these guys. So let's go ahead and start. 220. So my graph is going to be way up here. 1, 0. Notice how it's the same from the original. Then it goes 0, negative 9, the y-intercept. Then I'm going to go to negative 2 to negative 3. Then I'm going to go to negative 3, 0. And then I'm going to go to negative 4. And then it goes back to negative 5. Negative. Now I'm going to go ahead and graph this. Voila. So, D. Compare this function that we created with the degree function that you created in question 2. How are they similar? Well, let me go ahead and look at it what it is. R of x is equal to x plus 3. What was the algebraic representation of m of x? M of x was equal to x minus 1 times x plus 3. X minus 1 times x plus 3. Notice this is m of x. So let's go ahead and compare it side by side with r of x. Notice both of them are 3 degrees. The reason being is there are 3 parts to it. So it's going to be degree 3, which means all of them are going to have 3 solutions. The big thing I want you to notice, in P of x, you have 3 different solutions. What are they? What number minus 1 is 0? 1, negative 3, and negative 2. But in contrast, R of x has 3 solutions, but 2 of them are different. So it is still a degree 3. It just has a repeat in the answers. Negative 3, 1, and negative 3 again. This is known as having an answer with a multiplicity of 2. That's it for now.